Hi, my name is Avian Sapkota,
Hi, my name is Pradeep Dangal.
and this is a homework for number systems and digital logic. So, yeah, this is our questions list. So we have four questions. Two of them, one is related to addition, one is related to subtraction, and then the other two is related to
Floating number
floating
systems.
number systems. So to begin with the first one, I'm just adding 13 and 17 in binary. So for that, let me convert 13 and 17 to binary first. So let me just open up a paint here. So with it's seeing okay. So with 13, so let's just divide it by 2. So 2 6 12, so remainder would be 1. Similarly, 2 3s are 6 0, 2 1s are 2 1, 2 0 1. So it would be 1 1 0 1. 13 would be 1 1 0 1. So we got 13 is 1 1 0 1, and then the other number is 17. So with the same logic, we can do say for 17, we can do 2 a 6 7 7 14 15 16 2 8s 16, remainder 1, 2 4s 8 0, 2 2s 4 0, 2 1 0, 2 0 1. So it's gonna be 1 0 0 0 1. So we got 17 equals to 1 0 0 0 1. So now we are adding these two numbers. So we are adding 1, oops, 1 1 0 1 added to 1 triple 0 1. Let me do this. 1 okay, 1 0 0 0 1 added to 1 1 0 1. So it's gonna be 1 and 1 would be 10. The category would be 1. This one would be 1 1 0 1 1 0 1 1 1. So it would be, this would be the answer. So hence the answer to the first question is 1 1 1 1 0 1 1 1 1 0. This again converted to decimal would be 20 21 22 23 24. So this would be 0. So it would be 2 plus 4 plus 8 plus 16. So that's gonna be 16 and 4 makes 20 plus 10 30. So it is equivalent to 30. And then again from the previous, so 13 and 17. So this is 17 and this is 13. So these added would be 30. So this is how you do a binary addition. And then for the next question, I have Pradeep over here. So yeah, you can go ahead. I hope it's recording. Let me check. Yeah, yes, it is. Okay.
Hi, and I'm going to explain about the question number two. To convert the 5.75 to the binary floating number. So first, let me open the paint. So first, 5.75, the binary number, it's gonna be 101. That's the Obian already showed how to convert the number to the binary system. Oops, my bad. Okay. Mm, the binary number of 5 is gonna be 101, and the binary number of 0.75 gonna be 11. Okay. After this, so the binary number of 5.75 gonna be 101.11. All right. So after this, on the second step, we're gonna move this decimal point to the front. So each step, when we move the decimal point, we're gonna multiply by 2. So it's also called the scientific notification notation. So scientific notation gonna be 101 1 2 to the power 2. So we just move the decimal to the front, and when each move the decimal to the one place, it's gonna multiply by 2. So we move 2 places right here, 1 and 1, so that's the 2, and the base is gonna be 2. So after this we're gonna we found the scientific notation. After this we're gonna find the sign. Since the 5.75 number is positive, the sign is gonna be 0. If it was negative, it was supposed to be 1. So right here is 0. So after this we're gonna find the 8 digit binary exponential. They have given a certain bias number which is 127. So we're gonna add this to number 2 to 127. So 127 plus 2, it's gonna be 129, and the binary number for this 129, it's gonna be 10000 and 1. Okay, so we found the sign, we found the 8 digits, the binary exponential. After this, we're gonna find the 23 digit, 23 fraction bits. So the 23 fraction bits gonna be start with these numbers. It's gonna start 0, 1, 1, 1, and zeros. It's gonna go. I don't have a place to write over here, so it's gonna be 23 digits.
Okay. So the final number is gonna be. Let's probably make this a little bit bigger. Yeah, we can go over the final number.
So the final floating number for 5 point. Floating number for 5.75 is 0, 1, 0, 0, 0, 0, 0, 1, 2, 3, 4, 5, 6, 1. After that 0, 1, 1, 1, and zeros until we make the 23 bits. And that's the answer is gonna be the number A right here. All right.
Thank you. So the answer for the first one, I think I forgot to mention, it's gonna be the first one. I'm not sure if I can see the answers. Yeah. So for the first one, the answer is gonna be this. Second one's gonna be this. Now the third one is pretty simple subtraction, just to grab the concept. The same can be replicated for a lot of complex numbers. So it's gonna be 100 subtracted. 10 is gonna be subtracted from 100. So 0 minus 0 is 0, and then this 0 minus 1, we can't do this, so we get 1 from here. This becomes 0, and then this becomes 1. We just carried over 1 from the first bit, and then it's 1. So 1 uh, yeah, I'm sorry, we had to cut off the last one. So yeah, the so we were at this. So I realized that this one was being overlapped by our videos. I'll just put it over here. So yeah, we just okay, let me do this again. So so yeah, we had 100 minus 10. So 00 would be 0, and then 01 would be, so it's not possible. So we get this 1 to 0, and then this one would be 2, and then 2 minus 1 will be 1. So it's gonna be 1 0. So pretty much when you convert it into binary to 0 1 2, it's gonna be to 4 minus 0 1 2, and then it's gonna be 2. This is the equivalent of 2 in binary. So it's the binary subtraction, and then the answer would be 1 0. So this is the answer. So yeah, on to the next question with Pradeep.
Okay. Hi again. For the question number 4, we have chosen the number 6.25. It's the basically same as the question number 2, but it's gonna come out a different answer. So first, we find the binary number for 6. That's 110. We can After that we find the binary number for 0.25. That's 0 1. So after the exponential scientific exponential number is gonna be 1.1001 to the power 2 base, and since we move two decimal points, we shift two shifts for the
Steps,
decimals,
yes. Yeah.
so that's gonna be 2. Uh, After this, the sign is gonna be 0 again, because 6.25 is a positive number, so it's gonna be 0. The 8 digit uh, 8 digit exponential base gonna be 127 plus 2, since the 127 is the bias number given to us, and 2 is the number we move to the decimal, so that's going to be 129. I'll just clear this first. So the shift 0, the 129, the binary number for 129 gonna be the same as the before question. That's 10000, the 1, and the 23. 23 bits number is gonna be 1001. I didn't show any the steps because it's the same step as question number 2. So I just wanted to find the numbers so the base is gonna be solved. So the floating number for 6.25 is gonna be 0, 1, 0, 0, 0, 0, 1, 1, 0, 0, 1, and it's gonna be zeros till we make the 23 bits, 23 numbers, and that's I think it's the number 1. So the answer for the 6.25, the floating number of answer of 6.25 is the number A. And that's all our problems.
Yeah, these are our four problems, and then we hope the video went well. Thank you.
Thank you.